Well, hello, this is Nitin Dahad with EE Times. I'm speaking now to Praveen Vaidyanathan, who's General Manager for Memory at Micron Technology. Praveen, hello. Have I got your title right?
Then, very good morning to you. Absolutely, you got it right. It's a pleasure to talk to you.
Good. Well, we're talking because you've launched a new, a significant new product. We'll talk a little bit about that, but also then I'd like to just talk a little more broadly about where that fits, the market, and where things are going. Because obviously, anywhere you turn now, memory is hot.
Right. It's an exciting time to be in this industry for a lot of reasons. From the role of hardware in how it delivers valuable services to us as users, to us as businesses, has really transformed over the last 5 to 10 years. And in that ecosystem, the role of memory continues to be super important. And we're actually very excited to be in a role where we can participate in discussions around the role of memory. How can we develop new products that helps enhance the value of the ecosystem? And as a product and technology company, right, our goal is how do we lead? How do we be the first to go do a lot of these things that we all get to use in our everyday lives?
Yeah, and I think the reason it's got to be and like everybody uses AI, but AI in the sense it's being machine learning models being used both in data centers and at the edge. So whether it's mobile phones, whether it's the data center, you're just doing a lot more computation. You need that memory.
That's right. And actually, if I was to extend your insight a little bit further, what I would say is there is four key elements of memory that we constantly think about
Yeah,
in this framework. One is the bandwidth, how fast can you get the data out? Capacity, how quickly can you get the data? How much data can you get out? Right? Then the
yeah.
power, right? How can you do it efficiently? In today's world, power is a constraint, right? You got to do it power efficiently. And then the fourth element that is also becoming more important is just memory density, right? How much can you pack in a small space? Because people want
Mm.
more memory, more capacity, more bandwidth, but you don't have the space to go put it in. So how can you increase memory density, right? So a lot of interesting
Yeah.
challenges, but that's what makes us all come to work every day.
Well, yeah, I remember my BBC Micro with my Ziglan hard disk drive, and the thing we look at is how quickly you can get the read and write speeds and all that.
Right,
Because yeah, so
right.
I'm dating myself, but no, that leads your point leads us into how much you can pack in, and I think that leads us well into your new product launch. So just tell us about the SOCAMM2 launch.
Yeah. Um, Nathan, first of all, again, thank you for the opportunity. I think obviously we love to talk about this simply because it's something that we've been working towards for a long time. But today, what we're announcing is a capacity point for a low power DRAM based module. The form factor is called SOCAMM2 in the industry, which is small outline compression attached memory module. But we're announcing a 256 gigabyte capacity point for this that doesn't exist before this announcement. So we are first to provide that. And it's
Uh,
actually an
mm,
evolution. First of all, we've been working for almost 4 or 5 years on bringing low power DRAM into the data center, which didn't exist before. Once we did that, we last year we introduced the first modular form factor called SOCAM at 128 gigabyte capacity, right? That was the first it was introduced.
that was at GTC, wasn't it? Nvidia GTC last year.
You're
Okay,
right. It was at
2025.
GTC.
Yeah,
It was at GTC less than a year back.
yeah,
uh,
yeah.
we were preparing for the next one. Um, so it was less than a year back, 128 gigabyte capacity, and today we have doubled the capacity in less than 12 months. And that's the cadence and pace of innovation we are trying to drive in the industry.
Well, I mean, there's a maybe a backstory to all of this, and that's well, you've doubled the capacity, but according to the figures I see, and we'll go into the detail in a separate story in E Times, but third of the power consumption, third smaller footprint than standard RDIMMs, and faster. Tell us, like, that means more integration, all kinds of stuff. What's been involved in getting there?
No, you're absolutely right. I think maybe there are three elements I can articulate in what goes into doing this. The first is we are a manufacturing company. We focus a lot on developing the best technology. In fact, what drives innovation at its core is being able to go to smaller and smaller process nodes. Right. A few years back, we were on what is some called the 1 alpha, then we go to the 1 beta, then we go to the 1 gamma. So one of the key innovations that we were able to do is between last year and this year is we moved our low power DRAM product to this 1 gamma process technology, which allows us to do two things. One is it allows us to pack more in a given space. The second thing it does is it allows us to reduce our power consumption, right? And the third given is performance, right? Performance is almost a given these days that you deliver better performance, but we do it at lower power, right? That's one of the innovations around the process technology. The second element is design, right? Designing a
Yeah.
DRAM die and how do you structure that the right way. This design is actually based on what we call a monolithic 32 gigabit low power DRAM, whereas last year it was a 16 gigabit low power DRAM. So essentially, you
Mm.
get twice the number of bits in a single die. Now you have the process technology, you have the design, but you still need to package all of these things together into a component in a module. So the third innovation is focused on advanced packaging, where we are able to put 16 of these in a single package in the same footprint that we did last year, right? So the process technology, which is a 1 gamma, the design, which is 32 gigabit, plus stacking 16 of these in one package led us to basically go from 128 last year to 256 gig this year.
Now that stacking, I mean, is that like the 2D, 3D? How are you doing that?
So we use actually traditional wire bonding technology, which is
Okay.
actually one of the advantage for low power DRAM, as opposed to some of the other stacking technology that are being used in the industry because it is a little bit simpler. You still
Okay.
have to work on a lot of signal integrity and power distribution because you're stacking a lot of die together, but it's a little bit simpler and it allows us to actually stack 16 of these together,
Okay.
16 in a package
Got
together.
it.
So,
Got it.
yeah.
Now, I mean, still talking about that piece of innovation, I guess you had to throw a lot of resource to it because you talk about co-innovation. Obviously the co-innovation with Nvidia, and you're tied to a certain extent with their new product introduction cadence as well.
You're right. I mean, who hasn't heard about the 1 year cadence, right?
Yeah,
So I think that's the marching orders for everybody in the industry now. Um,
yeah.
but yeah, and the co-innovation is super important because you've got to understand the needs of the customer. You've got to understand the needs of the eventual platform you're trying to deliver. So working closely with a partner is the only way to do these things, right? So we've been pretty excited about working in that kind of a culture. Now it's interesting to talk about resources because right before we had released the previous product, we had already had a fairly big huddle inside Micron where we brought in the design leaders, we brought in technology leaders, we brought in customer go-to-market leaders, and we all got into a room for 2 days and said, how are we
I
going to?
can just imagine that room. I can just say,
Yes,
okay, how do we do this now?
yeah, yeah. It all started off with who came up with this idea, right? We cannot do it at this timeline to, at the end of the 2 days, you're like, this sounds great. Let's go get it done, right? And this is the culmination of that cross-functional effort in the company to go deliver a leadership product.
I mean, that says a little bit about your culture as well, I guess. Is that can-do culture within Micron? I mean, when I've spoken to people like Art DeGis at Synopsys, he
Right.
talks about that culture of how can I do it rather than it can't be done.
Yeah, no, absolutely. That is the culture of Micron. But the other thing is being able to get the reason we wanted to do that huddle for 2 days is you've got to get people together. You've got to be
Mm,
able to hear the opinions of different people. It may be dissent initially, but its dissent come from experience and
yeah.
it comes from having to manage challenges. And I think that was super useful because we understood where everybody was coming from and we could go focus on the right challenges, right? So I think the collaboration, the desire to get buy-in from multiple stakeholders, and once everybody gets to the same place to be able to march towards a solution, it is a culture that we are proud of, and we continue to go exact value out of.
Okay, I could talk forever on this, but let's go to the new product. So it's the 256 gigabyte SOCAMM2, the LPDRAM module, um, specifically targeted towards data center. Is that right?
That's right. Specifically towards data centers and also the application space that we think this product is going to be most valuable in, I'll say, driven by AI, right? As we have these larger and larger models, and as you go into inference, where the context windows, token lengths are becoming longer and longer. One of the concepts that's becoming important that I'm sure you and your users are very familiar with is about KV cache, right? The KV cache is kind of the short-term memory of AI, and
Mm,
you generate a lot of context that needs to be stored in near memory, right? So, and
correct.
we also think of KV cache as like a hot KV cache and a warm KV cache and a cold KV cache. The hot KV cache is something that resides in HBM, which is also a very exciting product from Micron, which is part of
Mm,
the AI infrastructure. The warm KV cache exists in low power DRAM in this case, and then the cold KV cache exists in fast SSDs, right? But so
okay.
this is very much trying to address that middle tier of warm KV cache, where from an inference perspective, you'll see some information we've released, where when you go from a previous solution that was available in the market to what we are delivering today, just by increasing the capacity, a key metric that everybody focuses on is called the time to first token, right? Which is like once I have a
Mhm.
prompt, how long does it take to get the first response? And that is user experience, right? And this one allows you to go to up to 2.3x the time to first token, right? It's 2.3x faster, um, which means for users, it's great experience. And even data centers, right? As you talk about monetization of AI, you need things like this so that you can pack more users in, you can get more responses out per second, and it just helps drive the whole token economy that we keep talking about.
Yeah, very interesting. And I guess although we're talking about AI, and this is specifically for that because you need it always on and reliable, but I mean potentially there's applications everywhere because obviously memory, yeah, low power, low cost memory is everywhere anyway, or required everywhere.
Right. I mean, you're absolutely right, Nitin. I mean, today, prior to this, actually, low power memory used in cell phones a lot. We see low power memory actually going into a lot of inference use cases in cars, in
Okay.
automotives,
Yeah. Yeah.
right? Laptops use low power memory, and now data centers use low power memory. You know, it's interesting. One statement I should make is we actually have some features on here that actually make it better suited for data centers that was not needed in some of the other applications don't have the high demands that data centers and servers have. But its low power memory has a very wide application in the industry, and it's a very strong part of our own portfolio.
Okay. What about the broader memory hierarchy? I mean, where does this fit?
Yeah, I mean, if I think about servers and data centers and various use cases, we've got, DDR, which is I'll say it's the workhorse of the industry, has been around for a long time. We go through various transitions of DDR3, 4, DDR5 is being used today, DDR6 is going to come in the future. So that's been the workhorse of the industry for long time. Um, HBM has taken main stage with the bandwidth requirements, right? There's no other memory that packs as much bandwidth in a given space as HBM does, and that's a very important part of the memory portfolio that we deliver, and that will be part of these subsystems too. Low power DRAM is a third element. I'd say it occupies the same level, very similar to a DDR in terms
Mm,
of the value proposition it provides. It just does it at much lower power, right? So
okay.
depending on
Yeah.
your use case, where you want that lower power, and you want to get that capacity through simple wire bonding techniques, LPDRAM is a great option, and that's what is happening now, right? People are
Well, that's why low power.
low power. Yeah, yeah, yeah. We make it easy for people to understand,
Yeah,
right?
exactly.
Names are not always well thought out. In this case, it makes sense.
Yeah,
Um, so DRAM, low power DRAM. There's also something called graphics DDR, which actually gets used in gaming applications. There are some applications where graphics is looking for a home and inference, and we'll see how the market evolves and how the needs of the industry evolve as inference becomes bigger. There could be a role for graphics DDR, but we're kind of still evaluating that. Once you get past these different hierarchies of memory, then you go into storage, right?
yeah,
Whereas if you want much higher capacity, but the latencies are higher, the speeds are different, then you go into SSDs, which is actually a very strong part of our portfolio. And when I was talking about the cold KV cache in the past,
yeah.
uh, those are starting to go into larger storage arrays, which is also very important of the entire hierarchy of memory and storage for these applications.
Okay. I think just to sort of close off the conversation, um, there are lots of different conversations around like memory access, compute things like computing memory. Where are the trends you see at the sort of longer term? I know like longer term doesn't mean much nowadays because longer term could be 2 years.
Right.
But what are you working on next, and what are the things that might be something that yeah maybe people should our listeners viewers should watch out for?
Yeah, so Nitin, I think maybe a little bit before we talk about what's coming, I like to think about how it's coming.
Yeah,
And what I mean by that is, I think what is important now is compute and memory have to be co-designed in terms of a solution, right? We
mm,
keep talking about some workloads are compute bound, some are memory bound, but that's not a clean cut, right? In an entire data flow architecture, sometimes you're compute bound, sometimes you're memory bound. So one thing that we are trying to do is how do we ensure that building on the elements of co-design that we've already done, how do we continue to co-design compute and memory, because that's the way to provide value to end
yeah,
customers, right? So that's going to be a key tenet of how we approach this. But on top of that, what's coming is, I think, the needs of the industry in terms of larger KV cache, more people adopting AI, larger concurrency, more
mm,
frontier models continuing to scale is going to continue to happen, right? The trend is very clear, right? If that
mm.
needs to happen, we as a company and your users should be expecting more memory capacity, higher bandwidth, better power efficiency as the key factors that will drive growth of memory technology in the future.
Now you've I think to your father's amusement stayed at you've been at Micron almost 30 years, and there's a backstory to that, but we won't go into that. But what excites you now? I think yeah, what's the big thing that yes makes you sort of get out of bed every day?
Yeah, yeah. I think the exciting part is, the opportunity to define the future of how we live our lives, right? At the end of the day, that's it, right? When you touch something, when you feel something, people just appreciate it more, right? And
Yeah,
us being able to deliver technology and products that I know at the end of the day, when somebody opens up Gemini and is running a prompt, I know we are there right behind it, right? To go enable that because the infrastructure uses are the products we deliver, right? So being able to go influence everyday lives of people is a huge motivating factor. It makes us all come in and say, how can we do things differently? And then the culture that you talked about, I think the culture we have at Micron that allows us to go operate this way is something that's probably kept me here for almost 30 years, and hopefully for as much longer as we are able to deliver innovation.
Well, I wonder what it'd be like when we both retire. But anyway,
That's
that's
right.
interesting. But well, Praveen Vaidyanathan, thank you very much.
Thank you, Nitin. It's been a pleasure talking to you.